Our solar system doesn't just end with Pluto, does it?
Nope.
It stretches out, way past the planets we know, into a ghostly, white-hot frontier where the sun's last breath is finally smothered by the sheer immensity of the galaxy itself. This isn't just theory anymore. Two aging robots, the Voyagers, just took that exit ramp, and the messages they're sending back are completely rewriting every space textbook on Earth. Ready to truly see what the edge of home actually looks like? Imagine standing at the shore of an invisible ocean, one where the water isn't just hot, it's a mind-boggling 50,000 Kelvin. The waves? They're made of superheated, magnetized plasma, and every single crash whispers a chilling truth. You've officially left the sun's protection. That's the Heliopause, our solar system's ultimate boundary, and for the first time in human history, we finally have witnesses. Back in 1977, NASA didn't just launch rockets. They hurled two Voyager probes like messages in bottles into the cosmic sea. Their mission was simple: keep flying until something, anything, stops them. For a staggering 35 years, the sun's relentless solar wind shoved against them, pushing out at 1,000,000 miles an hour, inflating a colossal magnetic bubble, a protective shield, if you will, that we all live inside. This entire region, dominated by our sun's influence, is called the heliosphere. Then, one by one, after decades of travel, these pioneering probes felt the wind slacken, drop, and finally, completely surrender. Voyager 1, the first to break free, crossed that invisible finish line at an astonishing 123 astronomical units. That's 11 billion miles from Earth. 6 years later, its sibling, Voyager 2, burst through a slightly thinner part of this cosmic bubble, proving that this finish line isn't some neat, perfect circle, but more like a wrinkled piece of cling film, constantly shifting and stretching. So, what's the first real sign you're getting close to the edge? It's something scientists call the termination shock. Think of it like a supersonic jet punching through its own sound barrier, only in reverse. Inside our heliosphere, the solar wind screams outward, moving faster than any local wave can possibly warn it to stop. But then, at about 90 AU from the sun, this supersonic wind finally hears the memo. It slams the brakes, abruptly turning subsonic, and piles up into a sluggish, churning layer. This turbulent region is known as the Helios Heath. Our intrepid probes didn't just zip through. They coasted through that cosmic traffic jam for years, navigating its chaotic currents before the real, definitive border finally appeared on their instruments. It's a bit like driving through thick fog before you hit the main gate. And then you reach it, the heliopause. Here, the sun's dwindling pressure finally balances the pressure of the interstellar medium, the stuff between the stars. The result isn't polite diplomacy or a gentle handshake. It's more like a chaotic, cosmic hand-to-hand combat. Magnetic field lines, those invisible highways of energy, snap, rejoin, and then snap again, releasing an incredible amount of energy. This process, known as magnetic reconnection, unleashes enough heat to bake the air around you to a searing 30 to 50,000 Kelvin. Voyager's plasma wave instrument recorded a narrow, screaming band of radio noise precisely where that solar wind died. A literal wall of fire so intense, it actually glows in wavelengths we can't even begin to see with human eyes. It's a fiery boundary, a true demarcation line where our sun's influence finally gives way. For years, scientists theorized that the galaxy's magnetic field would hit our solar bubble like two tornadoes colliding at utterly odd, unpredictable angles. It was a reasonable assumption, given the vastness and complexity of space. Instead, when Voyager's magnetometers finally took direct readings, they found something astonishing. The two fields were almost perfectly aligned. It was as if the galaxy had threaded the solar needle on purpose, creating an unexpected, elegant connection. This peculiar alignment isn't just a cosmic coincidence, it's a game changer. It allows particles to swap sides, meaning interstellar hydrogen can sneak into our heliosphere, while solar electrons can sneak out. This constant exchange makes the heliopause a dynamic, breathing boundary, expanding and contracting with every new solar storm back home. It's far from a static wall. It's a porous, ever-changing membrane. Inside our solar bubble, the heliosphere acts like a colossal invisible shield. Most high-energy galactic particles, dangerous cosmic rays from distant supernovae, are either deflected or significantly slowed down, protecting us here on Earth. But the very moment the Voyager probes crossed the heliopause, their radiation counters absolutely screamed. Galactic cosmic rays, these incredibly energetic particles from beyond our solar system, jumped by double-digit percentages in a single day. Picture this. You walk outside your house, and suddenly, the background radiation from everything around you doubles. That's precisely what happened to both Voyager probes. The heliopause is, quite literally, the solar system's last radiation shield. Once you're past it, the universe outside is revealed for what it truly is: harsher, far older, and significantly more radioactive. It's a stark reminder of our sun's protective embrace. If you're still picturing a neat, perfect sphere around the sun, you'd be completely wrong. The truth is much more complex and dynamic. The entire heliosphere is actually squashed on the side facing our orbit through the galaxy, and then stretched into an incredibly long tail on the backside, making it look far more like a comet than a symmetrical balloon. This irregular shape is a direct result of our sun's movement through the interstellar medium, which creates a kind of bow shock ahead of us and that elongated tail behind. What's more, the heliopause itself isn't rigid. It ripples and flexes like a flag in a strong wind, sometimes pushing inward to 110 AU, sometimes ballooning outward past 130 AU. Its exact position and shape are constantly changing, all depending on how many sunspots our star feels like making this decade and the varying pressure from the interstellar medium. It's a living, breathing cosmic boundary. Step past that wall of fire, past the radiation spike, and you're truly in a new medium altogether: interstellar space. It's cooler, yes, but also denser and subtly flavored with the faint ethereal dust of ancient supernovae. Temperatures out here might hover around 6,000 Kelvin, which sounds incredibly hot, right? But here's the trick. The densities are so incredibly low that a human hand wouldn't feel warm at all. The individual atoms are so far apart they would simply ping off your glove, barely registering. Yet the very fact that our machines can measure that temperature and can detect these subtle differences proves an incredible truth. Our probes are sailing an alien sea, one that is literally older than Earth itself. It's a profound transition from the familiar warmth of our solar home to the vast, cold embrace of the galaxy. The heliopause is so much more than just a finish line. It's our first real, tangible sample of interstellar weather. Think about it. Every 26 million years or so, our entire solar system bobs up and down through the galactic plane, sometimes diving into dense gas clouds, sometimes emerging into sparser regions. Understanding how our heliosphere, this protective bubble, flexes and filters radiation is absolutely crucial. It tells us how life on Earth has managed to survive those incredible, cosmic roller coaster rides. More than that, this knowledge teaches us how to design and build spacecraft that can truly survive journeys to other stars, where similar protective bubbles might shield other potentially habitable worlds. It's about securing humanity's future beyond our immediate cosmic backyard. The Voyagers are true marvels, but their power is dwindling slowly but surely. Instruments are shutting off one by one each year, a bittersweet testament to their incredible longevity. Engineers now have to painstakingly rotate power between heaters and radios, just to keep a handful of vital sensors alive. Yet every single byte of data beamed back, at a painfully slow 160 bits per second, slower than a 1980s modem, is gold. It's literally rewriting physics textbooks. These twin probes, with less memory than a modern flip phone, have achieved the impossible. They've mapped magnetic fields, plasma densities, and cosmic ray intensities in a region no human device had ever or could ever directly touch before. Their data is a priceless legacy, delivered by machines that are pushing the very limits of endurance. The story of the Heliopause doesn't end with Voyager. NASA's IMAP mission, the Interstellar Mapping and Acceleration Probe, is set to launch later this decade. Its goal? To park right at Earth's doorstep and create a comprehensive 3D map of the entire heliosphere using neutral atoms that slip through the boundary, giving us a global view Voyager never could. Meanwhile, New Horizons, the probe that gave us those stunning images of Pluto, is now far beyond it, listening for the same faint ultraviolet glow Voyager first spotted, a signature of the hydrogen wall formed by the interaction of solar and interstellar winds. Each new spacecraft isn't just another launch. It's another detective arriving at the cosmic crime scene, confirming alibis, challenging old assumptions, and, invariably, exposing brand new mysteries. The exploration continues. The Heliopause represents the farthest frontier humanity has directly touched, an incredible achievement. Yet it's still only a mere thousandth of the way to the very next star. Every graph we download, every whisper of data from these ancient probes, serves as a powerful reminder that exploration is incremental. It's stubborn, and yes, it is gloriously, beautifully slow. The probes that crossed this boundary carry golden records, tangible greetings, songs, and the very heartbeats of our species. So, in a profound sense, the edge of our solar system already carries a time-stamped love letter from a species that simply refuses to stay home. From the violent termination shock to the searing wall of fire, the Heliopause truly is the ultimate cosmic boundary. It's a dynamic plasma battlefield, a critical radiation switch, and the very last place the sun can confidently call its own. Two vintage robots, launched decades ago, phoned home to tell us that our protective bubble is far weirder, hotter, and significantly more porous than we ever dared to guess. Their whispered data, painstakingly collected over billions of miles, will undoubtedly guide every single starship we build next. The edge of home isn't a fence designed to keep us in. It's a vast, exhilarating frontier, and we've only just stuck our toe through the door. If you're enjoying this mind-bending ride to the very edge of our cosmic neighborhood, do us a favor and tap that like button. It tells the algorithm you want more deep space detective stories. And while you're at it, hit subscribe and ring the bell for future updates from the Voyager's continuing epic road trip.